So can you pull up our slides? There it is. Yeah, welcome everyone. I think we have folks have now made their way from the other building over to here. Great, great. I'm going to kick us off. I want to thank you all for being here. I'm Jessica Granderson. I'm a senior scientist and director of the Building Technology and Urban Systems Division. That's the home of the majority of our CalFlexHub researchers. I've really been looking forward to this discussion about how we can go about really tapping the full flexibility potential of our larger commercial buildings. And I couldn't convene a better panel, a better set of panelists to discuss these issues. I will not presume to be able to do a good job introducing them. I will let them introduce themselves more fully in just a few minutes. We have John Schoenfeld remotely from Infogrid, Kamaya Abreu from Voltus, and Terry Holtz from Uplight. They'll tell you more about who they are and what they do. Next slide, please. When we first started talking about decarbonization, we were pretty laser focused on of course, efficiency and on electrification and on clean grid. And as we've gained more fluency in that language of decarbonization, we've been able to really strengthen our vocabulary to recognize the importance of demand-side flexibility in delivering a clean grid that's reliable and affordable. Work from Berkeley Lab has shown that with aggressive demand-side efficiency and flexibility, we can avoid over $100 billion in costs to build out that bulk system nationally by the 2050 time period. That's before we even start accounting for the benefits that accrue at the distribution system level. Next slide, please. So in that vein of advancing a clean grid in California, we have clean electricity goals as well as a load shifting goal. So 100% clean electricity by 2045, an interim goal of 90% by 2035. Work also done at Berkeley Lab has informed our statewide load shifting goal. 7 gigawatts by 2030. That's apportioned into 4 gigawatts for resource adequacy and things like emergency flexibility, 3 gigawatts for the load modifying approaches, dynamic rates, and time of use. Go ahead. Thank you. So recent work from Brattle Group showed that, remember, 7 gigawatt state goal, showed over 7.5 gigawatts of cost-effective potential almost already here by 2035. I'm showing that on the left, that this is a 5x increase over today's capability. When you look at the portion of that that is attributable to the commercial and industrial sector, it's about 1,200 megawatts. That's shown in the bar chart on the right. That potential for the commercial sector associated with 94 million a year in avoided system costs. And so I want to kind of key you into maybe 2 points. First is what needs to change. Historically, manual flexibility has been effective in the commercial and industrial sector. But going forward, a changing grid is going to require that we deliver that flexibility more frequently and that we have even more flexible control of our end uses. That's going to increase the importance of automation. Second, that we have to act now to capitalize on that avoided cost potential. Every day that goes past, we have a narrowing window of opportunity to be able to reap those avoided cost benefits. We continue to invest in build out as we go. So, just with some of that table setting, I want to kick us off by asking each of our panelists to briefly introduce yourselves. Tell us what you're working on. We'll start with Kamaya, then we'll go to John, our remote participant, and then over to Terry.
Thank you so much, Jessica. My name is Kimaya Abreu. I work at Voltus. We are a demand response and DER aggregator. I'm on the regulatory affairs team. So my team works on market access and market rules to fully enable DERs to participate in market. John? Okay.
Speak in the mic, John.
Hi, everybody. I'm John Schoenfeld. I'm with Infogrid. Very sorry that I could not make it there in person for the event today. Infogrid focuses on a combination of building intelligence delivered through software and engineering support to help businesses decarbonize their portfolio and reduce their utility costs. My focus here is on advanced supervisory controls and how that can drive deeper savings and demand flexibility.
Hi, everyone. My name is Terry Holtz. I'm a senior product manager with Uplight. At Uplight, we deliver software solutions for energy providers like utilities, CCAs, or asset owners for customer engagement, enrollment, and demand-side flexibility platform. I'm specifically focused on our edge DERMs that's Uplight added to their portfolio when they acquired AutoGrid earlier this year. And even more focused right now, trying to help facilitate integration of new devices. So working on communication protocols and integration with local controls that includes commercial buildings.
Awesome. Can I have the room thank and welcome our panelists, please? All right, I'm going to ask John to kind of kick us off with some thoughts here. It's not just because you're remote, but John, we know that our commercial buildings controls are like routinely falling out of tune. We've got controls being overwritten. We've got components failing. We also know that if we're asking our buildings to do more and more demand flexibility, our operators need confidence that they can still deliver on those principal building services. How are you looking at how we can realize more extensive demand flexibility while still confronting those challenges of being able to keep our buildings commissioned and operating as intended?
Yeah, thank you, Jessica. I think that the two key considerations that come with commercial buildings, especially with existing buildings, is it breaks down to people and equipment. Buildings are full of people, of operators and occupants. Those operators and occupants have different needs, and those needs change. Those are not static. Occupants have comfort complaints. Operators need to adjust the building to meet those complaints. Occupants have different schedules, and operators have to adjust the building to meet those schedules. There's an unfortunate kind of theory out there that software is going to solve all of our problems, but in the built environment, that just really isn't the case. We can't expect that we can just install something and turn away and magically our buildings will operate more efficiently and will follow price signals without giving our building operators and occupants a way of providing feedback to those systems to make sure that they are working for them. So I think when we're talking about existing buildings, in order to be sticky, in order to be something that's not going to be turned off in a year or a month, we need to find ways to deliver that functionality while still meeting the operators where they are and giving them ways to tune those algorithms, to tune those inputs so that they can keep occupants in the buildings comfortable and happy. And that will make ultimately demand flexibility more successful. The other reality that we have to grapple with is the equipment within the building. Existing buildings today are complex and they are prone to maintenance issues. There are, literally thousands of sensors and equipment and controls within a modern building today that have been designed and installed by different people likely at different times. And that's really a recipe for maintenance issues. And so if our demand flexibility algorithms, our demand flexibility programs are relying on equipment to be operating in peak performance at all times, then we're really setting ourselves up for failure. Now, this is something where software can be a big part of the solution, where we can integrate modern FDD into our demand flexibility approaches so that software knows when equipment is non-functional and is able to work around those issues and still deliver some kind of performance, some kind of demand shedding as best possible, and alert those who need to be alerted to fix those issues. The final thing I'll say is that with demand flexibility, we have an opportunity for a 2-for-1. So while we use demand flexibility as somewhat of the carrot to incentivize buildings to install modern controls, to fix sensor issues, to fix mechanical issues, we can bring up the standard of maintenance in these buildings and reduce energy consumption, improve general efficiency, while also unlocking other revenue streams from demand response and real-time pricing.
Thanks, John, for those thoughts. I think you're hitting on some of the big ones around stickiness, around people, around performance, and particularly your comments there at the end. For years we've been talking about the day-to-day efficiency benefits as being useful in justifying the cost of the kind of modern infrastructure that we need to then be able to layer in additional intelligence to make sure controls are working right as intended, to bring in the automation and the communications that we need for the demand flexibility. And I saw, Terry, I saw you nodding a bit in appreciation of some of those remarks, and curious how this is coming up in some of your work as well.
Yeah, so I think similar to what John said, like the things we're working on is trying to improve connectivity with the devices that are located at these buildings, at least knowing when they're online or offline, so we don't try to use them when they're not available. Believe it or not, is still a very big issue for our clients, utilities, trying to dispatch capacity and realizing that half of this huge commercial building is not responding for whatever reason. So we're trying to help. We're like a software provider. We help utilities create these programs and operate them. So it's working with so many different stakeholders, the building owner, the local electrician who knows their building the best, and the company that has installed these controls. And there's so many players here trying to coordinate and help everyone. It is a challenge, in like standardization in communications protocol, processes, how to install this equipment would help tremendously. So this is also an area where we're trying to help as we can.
Maybe pull the thread on that a little bit with you, Terry, and ask, you're working in a lot of different program markets. You're serving both utilities as well as the C&I owners with your software. We kind of have been experiencing more and more that we need to kind of satisfy the totality of needs across these actors. What are you seeing out there around the technology sets and incentive models that are going to give high confidence in the resource to utilities and also be effective in attracting customers and delivering on that value proposition?
Yeah, so we, like you said, we're active on these like two sides of the problem. We have the C&I customers, we have our utility clients. Utilities want to know when things work or doesn't work. They want visibility into what the devices are doing. So that's what we're working on. Accepting more and more communications protocols. We talk to every OEM as a different way to communicating with their device. So that's something we help them kind of standardize, or at least make abstract to them, so that controlling a thermostat looks the same as controlling an EV or a commercial batteries. So in reality, it's much more complex than that. But the other part is, once we have improved that connectivity, then it's giving visibility to utilities into the data. And utilities have ADMS. Some of them have great terms. They don't always talk to each other. And what we offer to them is edge terms that provide an even deeper view into what these DERs are doing. We're also helping them connect these 2 or 3 systems, so they can know, they know what's going on at each node and at each DER if they want to. So increasing visibility helps them figure out whether a dispatch was successful, whether the VPP is delivering what it's supposed to be. So that's on one side. And then you mentioned, like, how do we kind of recruit or make VPPs and DR attractive to CNI building owners, is showing them the money, showing them how much their capacity can be monetized. And then there's a huge area of improvement for us here, is showing them what the existing programs can generate for them, and also showing them potentially what they could be getting on the market, or if working with utilities to design these programs together. So that's upfront. And I would say equally as important is showing them how they perform and how much revenue they generated, how much emissions they avoided. It's critically important. Otherwise, you're going to lose their motivation if the data takes weeks or months to arrive. So that's also something we are actively working on and improving. It's not always possible. We rely on our clients and customers' data to do that, but whenever we can, we try to facilitate and accelerate access to that data.
It's so interesting to hear you both talk about the challenges you face and the technologies that you're implementing in buildings to make some more sophisticated, responsive flexibility happen. And, you know, something we think about at Voltus is how to work with CNI customers, you know, who don't have all of these technologies, who don't have sophisticated building management systems or software, and how to still unlock that flexibility potential.
I guess I want to loop back through each of you and kind of take today's snapshot in value proposition, customer value proposition for CNI, and what is strongly resonating in different portions of the market for the uptake of demand flexibility in today's world. What's and maybe if you can share with us some insights on, you know, not only what is resonating, but what really is not resonating these days, as we think about John so clearly painted for us the picture of, yes, there's technology issues. We also have to think about the people side of the equation and how our technologies are comporting with the people who are there running the buildings and making key decisions. So have we landed our value proposition and resonant statements with different actors in the ecosystem out there?
I think that for our customers, their primary concern and the reason we're engaged, you know, 90% of the time is purely on the return on investment of lowering their utility costs. How we get there really doesn't matter as much as how much we can do. And one of the challenges with demand flexibility that I see, or I should say real-time pricing, is very few customers are willing to go the route of changing their utility rate schedule or their rate structure without an absolute certainty that they are not going to be charged more based on that change. So, you know, we're looking at, you know, their entire bill and how we can reduce based on what their current rate schedule is, And sometimes that means reducing demand, and sometimes that means reducing energy. And we look for other revenue streams as they're possible through DR or other programs. But it's finding the quickest way to that ROI. The unfortunate reality, I think, for the decarbonization focused customers is that while there is great carbon savings that can come from load shifting programs and demand flexibility, most we find are not using the same kind of carbon accounting that would let you unlock those kind of savings. Most are accounting based on annual factors for emissions. And so the differences between the reduced load at your 6 o'clock hour when the grid is the dirtiest is lost for most who are using that kind of annual accounting approach.
Terry, Kamaya?
Yeah, for us, for the CNI customers, we talk to I think the value stack is typically like threefold. There is the bill savings, like saving money in their utility bill. There is revenue generation from grid services. Market participation is something we're starting to hear, like we aggregate flexibility across multiple buildings, bid that into the market. And the third one, maybe I have a more optimistic take, is we see more and more 500 companies with sustainability goals that are asking us to prioritize greenhouse gas emission reductions as well as a revenue stream, even if it doesn't generate dollar value for them. It's something we start to see more and more. So that kind of encouraging for all of us here. But yeah, the region by region, depending on what part of the country you're in, the value stack is similar, but what it's made of is could be different. Could be less or more bill savings or market revenue, for example.
Yeah, I think Terry said it really well earlier. Cash is number one. Number two, some simplicity and some certainty that there won't be too much operational disruption. And I think this morning we heard from Achintya about one of the reasons for dynamic rates being to pull together and simplify the sort of fractured landscape of demand response and demand flex in California with a real multitude of programs. And something our customers are challenged by and that we are challenged by is this really shifting landscape. For example, the demand response auction mechanism program existed as a really extended pilot for a number of years, and it had problems, but was also an effective way to get demand response providing resource adequacy in market. And it was sunsetted last year, so 2025, no more DRAM. And those kinds of changes make it more difficult to give customers predictability and assurance that the investments they're making, the operational changes they're planning are going to have returns. And we, of course, try to insulate customers as much as possible from those changes, but that is the landscape that creates some challenges.
Mm-hmm. We're here to talk about our buildings, but also our ecosystem of distributed energy resources. And each of you in the comments so far, we've kind of touched on the classic and the traditional building loads. We've talked about the EVs or the batteries that you may be aggregating into VPP offerings. I think it's a lot easier to charge and discharge batteries than it is to get in here and muck around with building HVAC systems and lighting control systems and automation systems and the different protocols and on and on. It's like sometimes I'm asking myself, and I really want to hear our panelists' thoughts about this. Why are we talking about building loads and demand flexibility given the EV adoption trends and projections in California? Like, why are we still fighting the good fight in our buildings infrastructure? Whoever wants.
I can go. We want them all, right? We want every opportunity to get flexibility. So I think devices have physical constraints. They are all different. Some of them are better suited for some type of grid services. So at least at Uplight, we're trying to integrate as many as we can, as many types as we can. I also wanted to say, yeah, they have a different cost to dispatch as well. Some of them are cheaper to dispatch for short duration. Some of them are much more expensive. So you want to offer like kind of a toolbox to utilities or to whoever's managing these programs, and not have them like limited to one specific type of devices. I don't know if EVs are the best choice to dispatch for like a 4-hour event, for example, in the middle of the day. That's and I also want to say commercial buildings are here. They're already here. There's so much like untapped potential. We don't have to wait for EVs to come. When they come, we'll be ready. We'll add that to our tool belt. But for now, there's a lot of work we can do already to generate that flexibility.
Yeah, Terry said it so well. I'm just going to be basically quite repetitive. We wanted all approaches. And, you know, things like HVAC and load flexibility, they're existing assets. And aggregators like Bread and Butter, our origin story is unlocking that latent potential to flex. And, you know, why not figure out how to manage a load rather than, say, investing in a new battery? You can do both, of course, but there's so much untapped potential that can cost effectively be realized. You know, while EV penetration is on the rise and all the rest of it is happening.
Mm-hmm.
Yeah, I would just add a couple of things. Yeah, I mean, I would definitely first echo, you know, exactly what was said before. It's not either or, it's and. The other thing, as I mentioned before, is the 2-for-1 opportunity we get with existing buildings. If we drive demand flexibility of existing buildings, we will have to fix up those buildings to get there, and that will itself have efficiency gains and decarbonization gains. The other one is, you know, is when we're likely to be shedding load is, you know, right now the peak of the California grid is happening at 6 o'clock. That may not necessarily be the best time to limit limit charging of electric vehicles. It's right in the middle, or at least part of the daily commute. And so we might actually not have as much of that potential as we think there will be. And so, you know, buildings are still going to be a big part of the equation, and therefore we need to start soon. Thanks,
each of the three of you. It definitely resonates with me, the notion of, you know, as I said in the beginning, if we have a window of opportunity to take action to capitalize on avoided cost potential, we can't necessarily wait. Let's use all of the storage that's built into our buildings naturally as of today. You know, I think there will also be really, so the all of the above approach, as well as, I love that, John, the twofer, that, you know, as we are on our decarbonization journey, we are still, that path is going to still go right through our buildings, no matter what we do about it. So getting them into efficient operational mode and able to be used as a resource is just a win-win. I also, you know, kind of personally wonder sometimes about, we've already touched on the people and a lot of the complexities that are coming up as we do residential or C&I demand flexibility, and you know, fully uncovering what that looks like for people and the unique relationships that we as Americans have with our vehicles is also kind of some uncharted territory there. In addition, John, to your comments about when that load is available and how it corresponds to what the evolving grid conditions actually will be. And I think it's fascinating to think about how that unfolds in different grid regions across the country and nationally. I wanted to bring it back to, we started kind of touching on connections to the Flex Hub in some of the comments so far around different prices versus other mechanisms for eliciting that demand side flexibility. So in the work of the CalFlexHub, we're of course demonstrating today's technology readiness for those responding to more highly dynamic continuous prices. I'd like to loop back and ask each of you for additional thoughts around how you think about dynamic rates, their coexistence or not with more traditional market-based response, and perhaps some comments around the policies and market mechanisms that we need that we are not utilizing today. And we can think about that particularly from a California-centric lens.
Yeah, I'm happy to start. I have a lot of thoughts here. We think at Voltus that dynamic rates are great. They're an important tool in the toolbox for unlocking latent demand flexibility and reaching those load shift goals. But at the same time, we think there's an ongoing important role for traditional supply side DR. And what we'd really like to advocate for is a combination approach, dynamic pricing and supply side DR. So I'll first highlight some reasons that we think traditional DR, is still very relevant, even under, fully dynamic retail pricing. And the first is just loads have different capabilities, and there's some load flexibility that can be incentivized by traditional DR programs that is not going to be as responsive to dynamic rates. So, for example, a university campus maybe with a variety of older buildings, a field house, a library, and those buildings don't have the updated controls, the management technologies, and curtailing, doing a demand response event or load shifting requires manual intervention with a range of equipment around the buildings, equipment that isn't sort of integrated, and maybe there are only a couple of building managers that really know the ins and outs of these loads and these idiosyncratic buildings. Or you might consider just a large manufacturer for whom too frequent and especially unpredictable shifts away from their baseline energy usage are operationally prohibitive. So for both these kinds of customer classes, regular DR works, a handful of times a season. You can put in the effort with some advance notice to significantly curtail that load, especially if there's a predictable revenue stream associated. But the sort of daily shifting of dynamic rates is not a good match. So that's one reason traditional DR is great. Another is really about attracting capital. Again, those more predictable revenue streams can underwrite investment in new DER assets, whether that's load management technologies or batteries, thermal storage. And the savings associated with dynamic rates are less predictable. And, especially as we're moving from the pilot phase of dynamic rates in California to wider adoption, we still don't really know exactly what savings will be realized and how these programs will look. So capital investment from supply side DR is still important. And then I'll just briefly mention that traditional DR is great for emergency response. And as we shift some load flexibility from emergency DR programs to dynamic rates, there might be reliability implications. So those are some reasons Voltus is, still gung-ho about traditional DR. But what I'd really like to focus on for just a second is a possibility of a blended approach. And that might look like a customer with some portion of their load that is automated, is responsive, and then another portion of load that really works best with traditional DR events and dispatches. And as long as you have proper baselines and accounting, you can disaggregate the reduction that is performance against a DR event from behavior associated with the dynamic rate and make both work together. And we see that as like a good balance between the savings of DR and the confidence in your return on investment that you get with supply side DR. And I think that's an attractive combination for a lot of our large, sophisticated customers. And I'll end just, you mentioned policy. I think the way to enact this approach, which we see as unlocking the full potential of this sector, is first, of course, to roll out dynamic rates in a way that consider and allow for dual participation in supply side DR. And then the second is just to continue to grow and enable traditional DR, for instance, by enabling more resource adequacy, by more streamlined and increased accreditation, I think so, of DR capacity. Because like right now, Voltus would look around at the system and say, there's a lot of DR capacity that is not getting accredited under existing CPUC mechanisms. So that's a missed opportunity, and kind of taking these two approaches of more resource adequacy and a dual participation with dynamic rates, we think could be really exciting in getting resources off the sidelines and participating. Sorry, that was a bit long. I got into it.
As we knew you would be well poised to represent. So I heard dual participation. I heard definitely not a one size fits all, maybe hybrid approaches, not just dual, but simultaneously accessing load flexibility through different mechanisms at customer sites. And I want to catch some of John's thoughts on this as well around dynamic rates, traditional approaches, policies, and mechanisms that you think we need here in the state of California.
Yeah, I think I would echo a lot of what was just said. I think that the crux of it for me and for us is around baselining. Unfortunately, the holy grail of having both real-time pricing or something similar and DR at the same time, and having buildings benefit from both is limited by the fact that the way we are calculating, the way we are baselining for DR really makes it difficult to also then have real-time pricing. So if we're trying to shed load every day, we are essentially reducing our ability or our incentives for DR. And so having a more effective way to create that baseline so that we are able, or our customers are able to leverage both of those, I think is really important. I think because right now real-time pricing, dynamic pricing is in its infancy, there is less confidence, which means more customers are likely to default to a DR program if they are put to a choice. And so finding a way that we can balance and have customers benefit from both, I think is what is necessary, and those are the changes that are needed. The final thing I would say, and I think this was mentioned earlier, but I think it's worth echoing, is the lack of standardization of programs and pricing and baselining does make it quite a challenge for probably all of us on the panel here to service, California in general. And so better standardization between the IOUs, and I mean, this isn't even to mention the rest of the nation, would go a long way in making it easier for all of us to service customers, or for those customers that are, that have locations across multiple utilities. And the amount and the variety of the of DR programs, of pricing programs, of baselining strategies, just makes it a real challenge to, you know, create products that are going to be successful for all users.
Mm. A strong call there for working our way back to a higher degree of like commoditization across this flexibility as a resource programs, baselining approaches. Thank you for those perspectives, John. And Terry, it looks like you've got the last word for today.
Oh, wow. So maybe back to dynamic pricing. We're as a software provider, we're not as involved in rate design or policy making. We're really trying to help on the operational side of things. And I can tell you, dynamic pricing is adding a ton of complexity, right? And it's not a hit on dynamic pricing, but it's something to consider. I can give you maybe an example: a local East Bay with our favorite utility and an EV fleet depot. Having to optimize the fleet schedule charging with great constraints, so not being able to charge specific time of the day, plus dynamic pricing, plus responding to DR event in the afternoon. That's like 4 layers of optimization right there. Without software, that's close to impossible for this customer to execute. We're getting there, but it is very complex, and it also from the outside looks like a black box. Or why do we have so many constraints? It seems like it's not always coordinated between the end customer, the utility. So yes, we're ready. We have technology available, but at the same time, I think it needs to be rolled out in a more, maybe with more clarity in terms of what are we trying to achieve. And yeah, maybe I'll leave it at that.
Thank you, Terry. Thank you, panelists. Please join me in thanking our panelists today.
Thank you.